Hello students, how are you? In last video lecture, we studied the concept of Lowry-Bronsted or Lowry-Bronsted theory for acid and bases. In this video lecture, we are going to start our new point, that is the next concept for describing acid and bases. So the concept is called as Lewis theory. Lewis theory. Lewis concept for acid and bases. After Arrhenius and Lowry-Bronsted in 1923, scientist Lewis described the definitions of acid and bases. This is most advanced concept for explaining acid and bases yet so far. So now let us move to the concept of acid and bases according to Lewis. So according to Lewis, acid means the substance which can accept electrons. The substance which can accept electrons is called as acid. Then, what is the definition of base? According to Lewis, what is the definition of base? The substance which can donate proton. Reverse of this. The substance which can donates electrons, called as base. Okay. So acid means the substance which can accept electron. I am writing here electron acceptor. Electron acceptor. Okay. The substance which can donate electrons, that is electron donor. Electron donor. Okay. So this is how to the concept of acid and bases according to scientist Lewis. Okay. Now, in terms of acid, in last video lecture, we tell the detailed concept of base. Base, that is electron rich species. Remember that. Electron rich species. S minus minus, Cl minus, SO4 minus minus, then PO4 minus minus, ClO3 minus. Okay. So, what is the concept of acid in this point of view? In this point of view, it is electron deficient species. तुम्ही पार्ट 2 मध्ये शिकला असाल लेविस ऍसिड अँड लेविस बेस. That's electron deficient species. In 11th standard, I think you will study the electron rich species, that is Lewis base or Lewis acid. This is the Lewis base, also called as Lewis base. Electron deficient species, that is NO2 plus, H plus. Okay, then according to this, Al plus 3, etc. Okay, so this is the electron deficient species called as acid. You already know the more example for acid and bases, for electron deficient species and electron rich species. So this is the basic concept of acid and bases. So in short, electron acceptor is called as acid, and in short, electron donor is called as base. Okay, so now let us move to the example regarding for explaining acid and bases by using electronic concept. This concept is also called as electronic concept because only electrons evolved in the concept of acid and bases, that is electron acceptor or electron donor. So this theory is also called as electronic theory or electronic concept. Electronic concept for understanding acid and bases. So it is related to electrons. So That's why electron acceptor called as acid, electron donor called as base. So let us consider an example, that is hydrogen plus. Hydrogen plus means proton. How many electron present in hydrogen plus? In hydrogen there is one electron. Plus charge indicate एक इलेक्ट्रॉन गेला है, so H plus contains 0 electrons. Plus NH3 and hydrogen, so I am writing lone pair here, that side, NH3. You already know the structure of ammonia, so you are aware about that, because in last year chemical bonding chapter we studied one lone pair present in nitrogen, two lone pairs present in oxygen. Okay, three lone pairs only present in fluorine only. Okay, oxygen also carry, but three stable lone pair only present in case of fluorine, because electronegativity is high among 118 element. 118 element पैकी fluorine ची electronegativity जास्त असते त्यामुळे. So in here, so nitrogen contains lone pair of electron, that is one lone pair, two electrons. So nitrogen donates his electron to the H plus. Okay, so donates and accept. H plus ion accept electron. So electron acceptor is called as acid, and electron pair donor or electron donor is called as base. Is called as base. Okay, so how what is our product? So product is, so you already know it forms coordinate bond. Coordinate bond. Coordinate bond, it is a temporary bond indicated by an arrow, because it is a not official bonding, like not official bonding like ionic bond and covalent bond. It is an unofficial bond, because due for completion of octet, नायट्रोजनचा ऑक्टेट पूर्ण होण्यासाठी नायट्रोजन फक्त इलेक्ट्रॉन हायड्रोजनला देतो, बरोबर, तो कधी पण तुटू शकतो, म्हणून हा इंडिकेटेड बाय अ सिंगल एरो. हा बॉन्ड असतो कोऑर्डिनेट और डेटिव्ह बॉन्ड, और डेटिव्ह बॉन्ड, तिचं दुसरं नाव आहे डेटिव्ह बॉन्ड. ओके, सो दिस इज द concept for acid and bases according to Lewis theory. Okay, the species or the substance which can accept the electrons called as acid, or the substance which can donates proton, donates electron called as base. Electronic concept, electron देणारा base, electron घेणारा acid. Now let us move to the another example for understanding Lewis acid and base. I am only taking first example. Now let us move to the number 2 example. So for that type it will be BF3 boron trifluoride. Boron trifluoride. Atomic number of boron is hydrogen 1, hydrogen, helium, lithium, barium, boron. So number 5, configuration is 2 3. So only 3 electron present in outermost shell. So 3 electron combines with 3 fluorine atom. So no electron remaining in boron. Okay. Plus ammonia, I am taking ammonia in here also. Ammonia having 5 electrons, 3 electrons for bonding of hydrogen and 1 lone pair is remaining. Total 5. So in case of ammonia shifted or donates the electron pair to the BF3, boron trifluoride. BF3 accept these electron pairs, so it acts as acid, or also called as Lewis acid. So according to Lewis, the name is given by Lewis acid. So that is Lewis base. So you are simply called as base or Lewis base. Okay, so ammonia molecule donate electron, BF3 molecule accept electron. Electron donor and electron acceptor. Electron acceptor. So it is called as base and acid. Okay. So what is our product? What is our product in this reaction? So simply I am writing here BF3, okay, ammonia and H3, and these two electrons are donating by nitrogen to BF3 molecule. So indicated by an arrow. So this bond is called as coordinate bond. I am not going in details regarding coordinate bond because in 11th chapter we studied it more clearly. Okay, so hopefully you understand the concept of Lewis acid and bases. Okay, now there are only 3 concepts regarding acid and bases. So we studied Arrhenius concept, then Lowry-Bronsted concept, and then Lewis theory. Now we have to classify, shortcut for Arrhenius theory, then Lowry-Bronsted, then Lewis theory, Okay, according to Lowry-Bronsted or Arrhenius and Lewis, acid must be which contains hydrogen and gives H plus ion, called as acid. Then base, the substance which contains hydroxy group, OH group, and gives OH minus ion in their aqueous solution, called as base. Lowry-Bronsted concept, then acid is equal to Lowry-Bronsted concept based on proton donor and proton acceptor. Proton means H plus. I am simply writing here H plus donor. Okay, then base, proton acceptor, that is H plus acceptor. Okay, so that is base. According to Lewis, acid means electronic concept आहे. Lewis concept is called as electronic concept because त्याच्यानंतर कुठलीही concept आतापर्यंत आली नाहीये. 100 वर्ष होतील 2023 मध्ये, 1923 सांगितले. Then acid means electron pair acceptor or electron acceptor. Base, electron donor. This is how to write shortcut regarding this theory because these 3 theories are really very important for us. Okay, now our total acid and base concept are cleared right now. Now let us, if you want to take a screenshot of this. Okay, now let us move to the ionization of weak acid and weak bases. Let us move to the ionization of weak acid and weak bases. Ionization of weak acid and weak bases. We already know there are many examples regarding weak acid and weak bases. Weak acid included benzoic acid, formic acid, acetic acid. Weak base included NH4OH, then CH3NH, CH3, C2H5 thrice of Young. Okay, so if you want to understand weak base, NH4OH, CH3NH, CH3, C2H5 thrice Young. Okay, these are the example. Weak acid included CH3COOH, HCOOH. Then another example C6CH5COOH. These are the few examples regarding weak acid and weak bases. Now let us move to the ionization. in ionization or dissociation is not too much difference. Not too much difference regarding ionization and dissociation. Now, in case of HCl, point to be remember that in case of HCl, HCl is dissociated it as H plus and Cl minus. As we know, it is strong acid. It is strong acid. If I am taking 1 mole of HCl, then it will produces 1 mole of H plus and 1 mole of Cl minus ions. Total remaining 0. 1 मोल घेतलं, सगळंच्या सगळं डिसोसिएट झालं. 100 रुपये दिले, सगळे खर्च केले. ओके, इथं 0 आलं. त्या पद्धतीनं स्ट्रॉंग ऍसिड आहे म्हणजे रिव्हर्सिबली रिएक्शन इज नॉट पॉसिबल बिकॉज दीज आर द स्ट्रॉंग इलेक्ट्रोलाइट्स. ओके, इन केस ऑफ NaOH, point number 2, in case of NaOH, so it decomposes Na plus plus OH minus. If I am taking here 1 mole of NaOH, then it will produce 1 mole of Na plus and 1 mole of OH minus. Okay, because it is strong base. So point to be remember that in case of strong electrolyte, that is strong acid and strong base, reversible reaction is can't be possible. Hence, equilibrium is can't be established because these are the strong electrolytes. ओके, 1 मोल घेतलं, सगळंच्या सगळं डिसोसिएट झालं, बाकी काहीच राहू शकत नाही. यांची बाकी 0 शिल्लक काय राहणार नाही. त्यामुळं ह्यांचं आयोनायझेशन आणि डिसोसिएशन किंवा आयोनायझेशन आणि डिसोसिएशन इक्वल कन्सेप्ट आहेत. ह्यांचं आपण काढू शकत नाही कारण रिव्हर्सिबल रिएक्शन यांचे होत नाही. त्यामुळे आयोनायझेशन आपण जनरली वीक इलेक्ट्रोलाइटचं करतो, वीक ऍसिड अँड वीक बेस. ओके, रिव्हर्सिबल यांचं होऊ शकत नाही म्हणजे इक्विलिब्रियम येणारच नाही. 1 मोल घेतलं तर सगळं झालं, पुन्हा रिव्हर्स काय येणार कारण ते स्ट्रॉंग आहे. नाव त्यामुळे आपण वीक इलेक्ट्रोलाइटचं आयोनायझेशन किंवा डिसोसिएशन दोन्ही करतो. नाव लेट अस मूव टू द आयोनायझेशन ऑफ वीक ऍसिड. कन्सिडर वीक ऍसिड HA. कन्सिडर वीक ऍसिड HA. आता तुम्ही म्हणाल वीक ऍसिड HA का म्हटलं, माझ्या आडनावाचं इनिशियल का दिलं नाही. बरोबर, HA. सर इंडिकेट A फॉर ऍसिड. ओके, ऍसिड मध्ये काय असतो, जनरली सोल्युशन मध्ये तो H प्लस आयन देतो. बरोबर, आरएनएसच्या विचारानुसार H प्लस आयन देतो म्हणून ते नाव दिलेलं आहे HA. ओके, कारण की हे ओस्टवॉल्डनं सांगितलं आणि ओस्टवॉल्डची थिअरी ही ओस्टवॉल्डनं आरएनएस कडून उचललेली आहे. हे जे आपण करतोय का नाही, हे 1988 मध्ये ओस्टवॉल्डनं सांगितलंय, पुढे ते लॉ आहे आणि ओस्टवॉल्डनं आरएनएसच्या हिशोबाने उचलले, लेव्हीच्या हिशोबाने उचललेलं नाही थिअरी. त्यामुळे HA, A फॉर ऍसिड आणि ओस्टवॉल्डच्या नुसार आरएनएसच्या नुसार H प्लस आयन देणार. Solution contains hydrogen use H plus ion in their aqueous solution. So HA. Consider weak acid HA. So it dissociated it as HA. It dissociated as H plus plus A minus. H plus A minus. Okay. So these are the weak electrolyte. Point to be remember that strong electrolyte that is irreversible. Only one error is possible. Reversible reaction is can't be possible because a complete dissociation of reactant takes place. But in case of weak electrolyte, there is partial dissociation. As I told you earlier that suppose in here weak electrolyte CH3COOH, it produces CH3COO minus plus H plus. So another CH3C acetate ion and hydrogen plus ion combines together to form this also. Then two-way reaction is possible. Hence, in reversible reaction, we can solve the ionization and dissociation for weak acid and weak electrolyte. याचे मी 1 मोल घेतले, बरोबर, 1 मोल घेतले तर याचे किती डिसोसिएट होणार, 0.15 acetate ion आणि 0.15 H plus ion. So remaining undissociated किती, undissociated लास्ट पिक्चरला फॉर्म्युला सांगितलेला होता 1 minus 0.15, 1 minus अल्फा आठवतंय का, 0.85 या पद्धतीने. कारण हे वीक आहे, स्ट्रॉंग मध्ये बाकी काहीच राहत नाही ना, स्ट्रॉंगला बाकी 0 राहते. त्यामुळे ओके, त्यामुळे वीक इलेक्ट्रोलाइटच्या बाबतीमध्ये हे करायचं. नाउ इन केस ऑफ वीक ऍसिड HA, it is dissociated as H plus and A minus. So according to law of mass action in chapter 11 chapter number chemical equilibrium, according to law of mass action, dissociation constant is given by Kc. law of mass action काय करतो आठवतंय का? rate of reaction directly proportional to concentration of reactant divided by its concentration of reactant. So Kc, how to write Kc? Point to be remember, आठवतंय का नाही? Kc is equal to C raised to C divided by D raised to D divided by A raised to A आणि B raised to B. ओके, प्रोडक्टचं कॉन्सन्ट्रेशन त्यांचे कोएफिशियंट डिवाइडेड बाय रिएक्टंटचं कॉन्सन्ट्रेशन त्यांचे कोएफिशियंट. प्रोडक्ट कोण आहे? H plus, and its concentration always expressed in square bracket. So that's why I am writing here H plus in bracket A minus divided by HA. H plus A minus divided by HA. Okay. Now this is the Kc. Kc, it is the general term. We have to write HA. It is a weak acid. Okay. Now constant is denoted as Ka. आता सेमी कॉन्सन्ट्रेशन साठी होता तो जनरल फॉर्म्युला होता ना हा Kc जनरल. आता ऍसिड साठी आहे म्हणून मी Ka म्हटलं, बाकी काय केलं नाही. तर दिस इज द हाऊ टू राईट Kc इक्वेशन फॉर Kc by applying law of mass action. Okay, now what is the need to calculate Ka? So please remember that. So first of all, you have to understand how to write Ka. Consider weak acid HA, that is A for acid, H for hydrogen. This theory ionization of weak acid mainly based on Arrhenius concept because post-war Arrhenius सगळं घेतलेलं आहे. बरोबर. त्याच्यानंतर weak acid is dissociated it has H plus and A minus. So applying law of mass action Kc because I am A for acid, आपण बघतोय acid साठी. So C raised to C into D raised to D divided by A raised to A and B raised to B. So H concentration always expressed in square bracket. H plus in bracket A minus divided by HA. So what is the need for calculating Ka? Now let us consider weak acid. There are many weak acid in organic chemistry. So CH3COOH, C6H5COOH, then HCOOH, then HCN, then H2CO3. These are the few examples of weak acid. Let us consider that समजा वर्गामध्ये एक वर्ग आहे ज्याच्यामध्ये सगळे विद्यार्थी हे काय म्हणतात ढ आहेत बरोबर. तर त्या ढ विद्यार्थ्यांमध्ये सुद्धा कुणीतरी हुशार असेल ना, त्यांच्यात पण कुणीतरी बऱ्यापैकी असेल आणि मग ते ऑर्डर लावू शकतो ना. ढ विद्यार्थी आहेत म्हटल्यावरती काय त्यांची रँक लावू शकतो ना आपण, हा 1 नंबरला 2 नंबरला 3 नंबरला 4 नंबरला बरोबर. किंवा वर्गात सगळेच विद्यार्थी हुशार आहेत A to Z, तर सगळे हुशार आहेत की त्यांची रँक लावणार ना आपण 1 2 3. तसं आहे ते. हे सगळे वीक काय घेतले म्हणजे ढ काय पॅरलल होते वीक ऍसिड. सो त्यामध्ये सुद्धा कोणतरी हुशार असेल बरोबर. म्हणजे वीक ऍसिड मध्ये कोण स्ट्रॉंग आहे हे बघायचं. त्यासाठी इट इज नीड फॉर कॅल्क्युलेटिंग Ka. ओके, सो देन these are the weak acid and for this weak acid we have to calculate which is the most strongest acid among these. Okay, now let us make it simplify. I am simplifying that. So if I am taking a beaker, I am not writing 5 examples, I am taking just 3 examples. So I am drawing 3 beakers. Beaker number first contains 1 mole of acetic acid. Beaker number first contains 1 mole of acetic acid. Beaker number 2 contains 1 mole of benzoic acid. Then beaker number 3rd contains 1 mole of formic acid. Okay, so I am adding 1 mole of this to this respective beaker. Okay, after that dissociation process is completed. So final conclusion is that acetic acid is 50% dissociated. So out of 1 mole, 0.50 moles are dissociated. 0.50 moles are dissociated. Out of 1 mole, 50% dissociation takes place. Okay. In case of benzoic acid, 0.40 moles are dissociated. 0.40 moles are dissociated. Or in case of formic acid, there is 0.20 moles of formic acid is dissociated. So please tell me, in which beaker concentration of H plus ions is greater? So you directly tell me beaker number first having 50% dissociation. So it having more number of H plus ion as compared to this. So decreasing order be like that. Beaker number first contains more number of H plus ion. Then beaker number 2 contains less number of H plus ions as compared to this. And beaker number 3 having very less number of H plus ion as compared to these 1 and 2 beakers. पहिल्या बीकर मध्ये H प्लस आयनची संख्या जास्त, दुसऱ्या बीकर मध्ये कमी, तिसऱ्या बीकर मध्ये कमी. कारण डिसोसिएशनचा रेट फर्स्ट बीकर मध्ये 0.50% डिसोसिएशन, एक घेतलं अर्ध डिसोसिएशन झालं, या 40% डिसोसिएशन झाले आणि याचं 20% डिसोसिएशन झाले. म्हणजे ह्याला 50% मार्क पडले, याला 40% पडले, याला 20% पडली ना. हे सगळे ढच आहेत, पण त्याच्यामध्ये हुशार कोण आहे तो बघायचं. ओके. सो इन दॅट वे वी हॅव टू नीड फॉर कॅल्क्युलेटिंग Ka. So from this given data we clearly suggest that there is, so what is our formula for Ka? Concentration of H plus ion, concentration of A minus ion divided by concentration of Ha, concentration of Ha. Because beaker number first having more number of H plus ions, H plus ion जास्त असतील की Ka ची व्हॅल्यू जास्त असणार आहे ना. अलग लक्षात. And beaker number first having more number of H plus ions. So value of Ka is like that. I am writing here 7.7 into 10 to the power minus 4. No, I'm not confusing that. 7.7. So beaker number 2 contains less number of H plus ion as compared to. I am writing here only. So what was my mistake? It is C6H5COH. So what is the value for beaker number 2? That is equal to 6.4. And what is the value for Ka? Is equal to 5.1. Okay, so I am taking just random numbers or random figures. So you have to understand it. If the concentration of H plus ion is more, then value of Ka is more. So concentration of H plus ion is less, then value of Ka is less as compared to this. Because beaker number first having 50% dissociation, beaker number 2 having 40% dissociation, and beaker number 3 having 20%. 0.20 means 20% dissociation. So H plus ion ची संख्या एक बीकर मध्ये जास्त आहे, आणि जेवढे H plus ion ची संख्या जास्त तेवढी Ka ची व्हॅल्यू जास्त. हे लक्षात ठेवा. H plus ion ची संख्या जास्त तेवढी Ka ची व्हॅल्यू जास्त. त्यामुळे Ka चे अशा रँडमली एक नंबर लिहिले. So then in this given data we have to understand easily. So what is the need for Ka? What is the need for Ka to calculate? What is the need for Ka to calculate strong acids? Strong acid means not like that strong, like HCl, HNO3, not like that. Strong acid within weak acid. Strong acid within weak acid. Because all are these weak acids. All are these weak acid. बरोबर. आता स्पर्धेमध्ये सगळेच प्लेयर हे वीक आहे. तुम्ही असं स्पर्धेमध्ये भाग घेतला सगळेच दुबळे, रनिंगच्या स्पर्धेत सगळ्यांना पळायलाच येत नाही, सगळेच हारण्याची शक्यता जास्त आहे. पण त्याच्यामध्ये कोणतरी बारा असेल ना, यांच्यामध्ये हजार बऱ्यापैकी बोलते, सगळे ढ आहेत, यांच्यामध्ये जर कोणतरी हुशार आहे तसं. त्यामुळे हे सगळे वीक आहे, त्याच्यामधला स्ट्रॉंग ऍसिड कुठलं त्याची रँक 1, 2, 3 या पद्धतीने आपल्याला लावता येते. बरोबर. हे झालं डिसोसिएशन कॉन्स्टंट फॉर वीक ऍसिड्स. नाउ let us move to the dissociation constant for weak base. Dissociation constant for weak base. So let us consider weak base BOH. Let us consider weak base BOH. B stand for base. OH means Ionization of weak acid and weak base is given by scientist Oswald in 1988, and Oswald is theory is mainly based on Arrhenius theory. So OH the देणारा बेस असतो. So dissociation gives B plus plus OH minus. By applying law of mass action is given by Kc is equal to product upon reactant. Product means B plus in bracket OH minus divided by BOH. But in case of base B, so we have to write here Kb. Okay, we have to write here Kb. Now there are many weak bases are there like NH4OH. Okay, then I am writing here CH3NH CH3. Now C2H5 thrice of N. There are many examples of weak base. I am just tentatively taking 3 examples. So these are the weak base. Okay. पण या वीक बस मध्ये सुद्धा कोणीतरी स्ट्रॉंग आहे ना, या तिघांमध्ये जरा बऱ्यापैकी शक्तिशाली कोण आहे, मग हा 2 नंबरला आहे, हा 1 नंबरला, हा 2 नंबरला, 3 नंबरला कॅल्क्युलेट करतो. बरोबर. मग मगाच्या सारखंच आहे. द नंबर ऑफ डिसोसिएशन ऑफ OH मायनस आयन. समजा याचं NH4OH चं डिसोसिएशन किती झालं, वी हॅव टेकिंग रँडम नंबर्स ॲज लाईक दॅट. 0.50 मोल डिसोसिएशन झाले आउट ऑफ 1 मोल. त्यानंतर CH3 it dissociated as 0.40 moles. Then C2H5 thrice N it dissociated it as 0.20 moles. So we clearly suggest that concentration of OH minus ions is greater in this beaker. Concentration of OH minus ions is greater in this beaker, and then the value of Kb is greater in NH4OH. Because concentration of OH minus greater, value of Kb is greater. जसं H plus जास्त, Ka ची व्हॅल्यू जास्त, OH minus जास्त, तसं Kb ची व्हॅल्यू जास्त. आणि OH minus जास्त कसं कळणार, डिसोसिएशन जास्त. डिसोसिएशन जास्त कसं, 1 मोल घेतले 50% डिसोसिएशन झालं, जास्त झालं. डिसोसिएशन जास्त झालं म्हणजे जास्त आयन सेपरेट झाले. डिसोसिएशन जास्त झालं म्हणजे जास्त आयन सेपरेट झाले. तसं ते आहे. दिस इज द need of calculating Kb. Okay, now in this lecture we studied ionization of weak acid weak base, that is weak acid Ha and weak base BOH. From this data we derive the expression for Ostwald dilution law for weak acid and weak base in next video lecture. Hopefully you have understood this video lecture. Thank you.